Well, good morning, my Algebra students. We are finishing up this chapter 4 of linear equations, linear functions with slopes of parallel and perpendicular lines. Why would we be talking about this? Because there is such a simple way to see if something is parallel or perpendicular. Let's check it out. So parallel lines have the same slope, Think about stairs for a second. If I am rising and running the same, then obviously I'm going to be parallel. Let's draw it out. It's always easier to see it on a graph. We're going to graph this equation. My y-intercept is 2, right? Let me just change this color so you can actually see it. My y-intercept is 2, and my slope is 2 over 1, right? I'm rising and running 2, rising up 2, running over 1, right? Now, if I draw another line, and I have the same slope. It doesn't really matter where the y-intercept is, but for this purpose, we'll use -4, but we have the same slope. You can see that they're parallel. These lines will never touch because they're parallel lines, right? They're exactly the same, but they just have a different y-intercept, right? Just a different. So we could pick another point if we wanted to. Right? And it would do the same thing. Now, perpendicular lines are lines that meet at exactly 90 degrees. They make 4 right angles. They have opposite reciprocal slopes, right? Opposite means if it's positive, it's negative. If it's negative, it's positive. And reciprocal means to flip it over. So if I'm given the slope 2/3, it would be negative because it went from positive to negative, and then it's a reflipical or flipping it over, right? Negative flipping, right? Opposite reciprocal. Let's look at another one. If I have -4 is my slope, well, that's actually -4 over 1, right? Then opposite means it's going to be positive, and reflipical means I have to flip it over. So it's going to be positive 1/4. Positive 1/4. Let's go ahead and check another. If I have 1/2, that's positive. So it's obviously going to be negative, and then -2 over 1 because I flipped it over, which is just -2. -2. Opposite reciprocal. Opposite reciprocal. So, of course, always let's look at it on a graph. Let's prove it, right? I don't want you to ever just memorize something for memorization's sake. I want you to know it. Let's graph this line. -4 is my y-intercept. 2 is my slope. Now, if I change this to be opposite reciprocal slope, right? So that means I'm going to have a -1/2 because from 2 goes to -2, and then reflipical, flip it over, right? I'm going to go ahead and start with my y-intercept is 1, and my slope is down 1 over 2, and you can see that they cross over, making 4 right angles, right? It is perfectly perpendicular. We can try another line if you want. We can even have the exact same slope as our first equation. And you can see that because the y-intercept is -4, and on the first one, the y-intercept is -4, that the only thing that changes is the slope to opposite reciprocal. It makes it perfectly perpendicular. So let's just practice this idea. Are these lines parallel or perpendicular? For number 1, if I have the 2/3 slope to -3 over 2 slope, this is obviously perpendicular, right? It's all about the slope. These have the same slope, right? The same slope, therefore they're parallel. What about this one? Well, in front of every x, if there's no actual number, that means that this would be 1, right? But we could also say it's 1 over 1. And then this is just negative 1 over 1. And that means it is opposite reciprocal, so it is perpendicular. How about from 3/4 to 4/3? Is that parallel or perpendicular? Well, we would say it's neither, because it flipped over, but it did not become opposite. Okay, go ahead and give me the parallel and perpendicular slope of both of these lines. You can write the equation, but you can just write these down and see if you get it right. If you're watching this video again, you can just pause it and then check your work. So the parallel slope will be the same, and the perpendicular is opposite reciprocal, so -6. For this one, the same as -3, and perpendicular would be opposite reciprocal or positive 1/3. Okay, let's look at what we're going to do if I have this equation of the line y equals 5x plus 10, and I want it to be parallel to this line and goes through this specific point, right? So I have to know that it goes to that specific point. Well, I use my point slope form. There's one of two ways to solve for this. If I use my point slope form, because I'm given a point, which it asks us to go through 4, 5, with a slope of 5. Now we know it's 5 because it's parallel, so it's the same slope. So if I'm given a point and a slope, I use the point slope form, right? Obviously. So I want to use this point slope form. And I plug in what I know, and I solve for what I don't know. I know that the point is 4, 5, and my slope is 5. And I go ahead and solve. I distribute 5 times x and 5 times -4, and I solve for the new equation of the line. So this equation of the line, y equals 5x minus 15, will be parallel to our other line. And more importantly, it goes through this point right there, which is what it had to do. Which is not any old parallel line, that would be just the same slope, but it had to go through that point. Therefore, it has to have a different y-intercept, a specific y-intercept. Let's look at another way to do this, and that's just using our formula, y equals mx plus b. And again, I'm given a point and a slope. So if I'm given a point and a slope, I can write the equation of the line because all I have to do is solve for the new y-intercept, right? So I know that 5, that's my y value, equals my slope times my x plus b. And I need to solve for this new b. So I multiply and I isolate my b value, and I get b is -15, which gives us the exact same answer as our point slope form, right? Y equals 5x minus 15, which is the answer to what is parallel to y equals 5x plus 10 and passes through the point 4, 5, most importantly. Okay, let's look at another example. Write an equation of the line in slope-intercept form that passes through 6, -4, and is parallel to 1/2 x minus 6. So we know it's going to have the same slope, but it has to go through this very specific point, right? This is where it matters, right? The details matter. It has to go through this point, right? So I'm going to try the first one using y equals mx plus b. I plug in my y value, -4, equals my slope, which is the same, times my x, which is 6, plus b. And I need to solve for the new b. So 1/2 of 6 is 3. I subtract 3 from both sides, solving for my new b value, getting y equals 1/2 x minus 7. Now, if I use my point slope form, because I'm given a point right here, and the slope, which is the same, right? I can use my y minus y1, so y minus -4 equals my slope, 1/2, times x minus the x value, which is 6. And I go ahead and distribute and solve for y. And I get the exact same thing, right? 2 ways to solve. The nice thing about doing point slope form is it gets you ready for Algebra 2 later. So go ahead and try this one, pause the video, and then check your solution when you're ready. And we get y equals -1/2 x minus 4. We're going to go ahead and go through this one now, where we're going through the line, going through the point 3, 2, and this time it's perpendicular. Perpendicular, right? Really important that it has to go through that point. So that's fine, because we know it's just an opposite reciprocal slope, right? Opposite reciprocal slope. So instead of being 3, it's -1/3. And we can do our 2 ways, right? We have a point and a slope. We can use our y equals mx plus b, plug in what we know. We know the y, we know the slope, we know the x, and solve for what we don't know, which is the new y-intercept. Now, often what people will make a mistake is they'll forget that this value has to change. You have to solve for it, right? So now if I choose to use my point slope form, right, if I have a point and a slope, and people tend to make less errors with this one, that's another reason why to use it. We put in our point, which is y value is 2, and x is 3, and our new slope, which is -1/3. And we go ahead and distribute. And solve. And we get the same thing. We have to, right? Okay, make sure you get all of the puzzle done, showing your work on a separate sheet of paper, because this will help you do well as we go into our final study guides, final quizzes, and literally going into finals pretty soon. All right, you got this, you can do it. Oh, one last few try if you want to try it. Pause it and check your video.